The following is a course module from Basic Algebra Concepts, available at argotsmedia.com. Click here as we see what it means for two variables to vary directly. When you're done with the video, be sure to click here to continue with your work. When we know or assume that two variables vary directly, we mean their ratio, the fraction formed from their values, is always the same number. When we know or assume that two variables vary directly, we mean their ratio, the fraction formed from their values, is always the
You're right. Their ratio is always the same number or value.
Click here as we see how we can use ratios to make proportions. When you're done with the video, be sure to click here to continue with your work. If we know or assume that x varies directly with y, then at a first point in time, the ratio of the values of x and y, y sub 1 over x sub 1, is equal to some value. And at a second point in time, the ratio of the values of x and y sub 2 over x sub 2, are equal to the same value. And we can say, if we know that the value of y at one point in time over the value of x at one point in time equals some value, and if we know that the value of y at a second point in time over the value of x at that point in time is equal to the same value, then we can say that the value of y at the second point in time over the value of x at that point in time is equal to the value of y at the other point in time over the value of x at that point in time. And this can be a very useful equation, but it is only true if we know that the variables x and y vary directly. If y sub 1 over x sub 1 equals some value, and y sub 2 over x sub 2 equals the same value, then which of the following equations is true?
Nicely done. Y sub 2 over x sub 2 is equal to y sub 1 over x sub 1.
Click here as we formally define a proportion. When you're done with the video, be sure to click here to continue with your work. An equality statement that simply says that two ratios are equal is called a proportion. When we have y sub 2 over x sub 2 is equal to y sub 1 over x sub 1, we have an example of a proportion. An equality statement that simply says that are equal is called a proportion.
Good work. An equality statement that simply says that two ratios are equal is called a proportion. Answer choice B.
Click here as we see how we can use proportions. When you're done with the video, be sure to click here to continue with your work. Proportions are very useful for solving problems in predicting the values of variables at a second point in time when values are only known for a first point in time. If we know or assume that x and y vary directly, in other words, always form the same ratio value, we can predict x or y at a second point in time if we know x and y at a first point in time. Let's see what we mean. If at a first point in time, x should have the value star, and y should have the value diamond, then at a second point in time, if x has the value triangle, we can predict, using a proportion, what the value of y is at that point in time. If we know or assume that x and y vary directly, in other words, that they always form the same ratio value, we can x or y at a second point in time if we know x and y at a first point in time.
Good work. We can predict x or y at a second point in time if we know x and y at the first point in time.
Click here as we begin to use our proportion to predict a value for y sub 2. When you're done with the video, be sure to click here to continue with your work. Let's see how we can find the value of y at the second point in time using our proportion. First of all, remember, at the first point in time, x had the value star, so we replace x sub 1 with star. And at that same point in time, y had the value diamond, so we replace y sub 1 with the diamond. Now, at a second point in time, x had the value triangle, so we replace x sub 2 with the triangle value. And we want to use these values to predict the value of y at the second point in time. And we can use our proportion to do that. Which of the following shows the correct replacements in the proportion?
Good work. Answer choice C shows the correct replacements in the proportion.
Click here for our next step in solving the proportion. When you're done with the video, be sure to click here to continue with your work. We are at this point now. And remember, our goal is to make the proportion talk about y sub 2 all alone. We have y sub 2 over the triangle. Y sub 2 is being divided by the triangle. We know to make this talk about y sub 2 all alone, we need to multiply this fraction by the triangle. So our first step in solving this proportion, this equality statement, will be to multiply the left-hand side of the proportion by the triangle. And our rules say that we must multiply the right-hand side of the equation as well by the same expression, the triangle, in order to still have an equality statement that is true. The next step in solving this proportion is which of the following?
Very nice. Answer choice A is the next step in solving this proportion.
Click here as we finish solving our proportion pattern. When you're done with the video, be sure to click here to continue with your work. We are at this point. We have the triangle multiplying times y sub 2 over the triangle. And we know that that result will be y sub 2 is equal to, we rewrite the right-hand side of the equation. We can't calculate those expressions because we don't know what values they represent. The next step in solving this proportion is which of the following?
Good work. Answer choice C is the next step in solving this proportion.
Click here as we begin our first example of solving a proportion. When you're done with the video, be sure to click here to continue with your work. Again, if we know or assume that x and y vary directly, in other words, that they always form the same ratio value, we can predict x or y at a second point in time if we know x and y at a first point in time. Let's look at an example. If at a first point in time x has the value equal to 2, and at the same point in time y has a value equal to 6, then at a second point in time, if x has a value equal to 5, we want to find the value of y at that point in time. Let's see how we can use our proportion to begin to find the value of y at this second point in time. First of all, at the first point in time, x is equal to 2, so we replace x sub 1 with 2. At that same point in time, y is equal to 6, so we replace y sub 1 with 6. Then, at a second point in time, x is equal to 5, so we replace x sub 2 with the value 5. And our goal is to find the value of y at that second point in time. And we can use our proportion to do this. The correct replacements in this proportion are which of the following?
You're right. The correct replacements in this proportion is answer choice A.
Click here as we go on to the next step in our example. When you're done with the video, be sure to click here to continue with your work. We are at this point now. We have replaced the variables in our proportion with our values, and we're ready to go on to solve our proportion. We have y sub 2 over 5. Y sub 2 is being divided by 5. We know to make that expression talk about y sub 2 all alone, we need to multiply the fraction y sub 2 over 5 by 5. So our first step in solving this proportion will be to multiply the left-hand side of the proportion by 5. And we must do the same thing to the right-hand side in order to still have a true statement. The next step in the solution of this proportion is which of the following?
You're right. We need to multiply both sides by 5.
Click here as we calculate our solution value for our proportion. When you're done with the video, be sure to click here to continue with your work. We are at this point right now. We have 5 times y sub 2 over 5 equals 6 over 2 times 5. We know that 5 times anything over 5 will be that thing. 5 times y sub 2 over 5 calculates to be y sub 2 all alone. And that will be equal to, we can calculate 6 over 2 is 3 times 5 is 15. Y sub 2 is equal to 15. So we can say, at a first point in time, if x has the value 2 and y has the value 6, then at a second point in time, if x has the value 5, y will have the value 15. Again, this is because we know that x and y vary directly. The next step in the solution of this proportion is which of the following?
Nicely done. Answer choice C, 15, is the solution of this proportion.
Click here as we see how we can use a proportion to solve an everyday problem. When you're done with the video, be sure to click here to continue with your work. We are baking chocolate chip cookies, and our recipe tells us that 40 cookies require 1 bag of chocolate chips. And that also means, since we're using a recipe, that the number of chocolate chips and the number of cookies vary directly. Our problem is we want to make 100 cookies, and we need to figure out how many bags of chocolate chips we need for 100 cookies. Let's let x represent the number of cookies and y represent the number of bags of chocolate chips. Then when we talk about 40 cookies require 1 bag of chocolate chips, that's saying that at one point in time we have 40 cookies, and at that same point in time we have 1 bag of chocolate chips. We can say 40 is x sub 1, and 1 is y sub 1. And we want to know, if we have 100 cookies at a second point in time, how many bags of chocolate chips are required. Let's organize our information into a table. Again, at a first point in time, we have 40 cookies. And at that same point in time, we use 1 bag of chocolate chips. At a second point in time, we want to make 100 cookies. And we need to find out how many bags of chocolate chips are required to do that. X sub 1 is 40 cookies, so we replace X sub 1 in our proportion with 40 cookies. Y sub 1 is 1 bag. 40 cookies use 1 bag of chocolate chips. At a different point in time, we want to make 100 cookies. X sub 2 is 100 cookies. And we want to know, at that second point in time when we're making 100 cookies, how many bags of chocolate chips are required to do that. Which of the following are the correct replacements in the proportion?
You're right. Answer choice B are the correct replacements in the proportion.
Click here as we go on to our next step in solving the proportion. When you're done with the video, be sure to click here to continue with your work. We are at this point. We know that we need 1 bag of chocolate chips to make 40 cookies. We want to figure out, if we want to make 100 cookies, how many bags of chocolate chips do we need? Looking at our proportion, we see that we have y sub 2 bags over 100 cookies. We know that we need to multiply this fraction expression by the bottom, the denominator of the fraction, in order to make it talk about the top all alone. So our first step with this proportion is, with the left-hand side of the proportion, we multiply by 100 cookies. And we know that we have to multiply the right-hand side of the proportion by the same expression, 100 cookies, in order to still have a true statement. Which of the following is the next step in the solution of the proportion?
Correct. Answer choice A is the next step in the solution.
Click here for our next step in solving our proportion. When you're done with the video, be sure to click here to continue with your work. We have 100 cookies times y sub 2 bags over 100 cookies. If we have something like A times B over C, this can be written as A times B all over C. And we are going to do that here with our expression 100 cookies times y sub 2 bags over 100 cookies. This can be written as 100 cookies times y sub 2 bags over 100 cookies. In the same way, we can write on the right-hand side 1 bag times 100 cookies all over 40 cookies. Which of the following is the next step in the solution of the proportion?
Good. Our next step is C.
Click here as we calculate with our units. When you're done with the video, be sure to click here to continue with your work. Remember, anything over itself is equal to 1. And looking at our equation, 100 over 100 is equal to 1. Cookies unit over cookies unit is equal to 1. Times y sub 2 times the bags unit is equal to, looking at the right-hand side of the equation, again, cookies over cookies is equal to 1 times 1 times the bags unit times 100 over 40. Which of the following is the next step in the solution of the proportion?
Nicely done. Answer choice A is the next step in our solution.
Click here as we find out how many bags of chocolate chips are required. When you're done with the video, be sure to click here to continue with your work. Going on with our calculation, 1 times 1 times y sub 2 bags is y sub 2 bags, and that is equal to 1 times 100 is 100 bags over 40. Y sub 2 bags equals 100 over 40 is 2.5 bags, or in decimal form, 2.5 bags. So we can say this. If at a first point in time we have 40 cookies and it requires 1 bag of chocolate chips to make those 40 cookies, at a second point in time, if we wish to make 100 cookies, we need 2.5 bags of chocolate chips in order to do that. And we were able to calculate this because the number of bags of chocolate chips varies directly with the number of cookies that we want to make. Which of the following is the next step in the solution of the proportion?
Good work. Answer choice B is the next step.
Click here as we look at another example of using proportions to solve a problem. When you're done with the video, be sure to click here to continue with your work. Let's look at a different problem. If we are driving at the same speed on the same kinds of roads, then the distance and gas usage vary directly. If we use 2 tanks of gas when we travel 500 miles, we want to know how many tanks of gas we need if we go 1,250 miles. We can solve this problem using a proportion. We begin by letting x equal the number of miles traveled and y equals the number of tanks of gas that are used. We can think of 500 miles as x sub 1 and 2 tanks of gas as y sub 1, and 1,250 miles as x sub 2, and how many tanks of gas we need to go that distance as y sub 2. Let's organize our information into a table. At a first point in time, the number of miles traveled is 500 miles, and it takes 2 tanks of gas to do that. At a second point in time, we travel 1,250 miles, and we want to know how many tanks of gas are required to do that. Let's place our values into our proportion. First of all, x sub 1 is 500 miles, and we replace x sub 1 in our proportion with 500 miles. Y sub 1 is 2 tanks. We replace y sub 1 with 2 tanks. At a second point in time, x sub 2 is equal to 1,250 miles, and we replace x sub 2 by that value. Y sub 2 is what we want to calculate. How many tanks of gas are required to go 1,250 miles? Which of the following are the correct replacements in the proportion?
Nicely done. Answer choice C is the correct replacements in the proportion.
Click here as we begin to solve our proportion. We are at this point. We know that a 500-mile trip requires 2 tanks of gas. We want to go 1,250 miles, and we need to figure out how much gas, how many tanks of gas we need to do that. We can use our proportion to do this. Looking at our proportion, we see that we have y sub 2 over 1,250. We know if we're trying to solve for y sub 2, we are going to have to multiply by 1,250. So our first step is, with the left-hand side of the proportion, to multiply it by the expression 1,250 miles. And our rules tell us that we must do the same thing to the right-hand side of the equation. So the right-hand side of the equation must be multiplied by the same expression. In order to still have a true statement. Which of the following is the next step in the solution of the proportion?
Good work. Answer choice B is next.
Click here as we continue with our solution of the proportion. When you're done with the video, be sure to click here to continue with your work. Our equation is at this point, and we can easily show with our rules that this pattern is true, that if we have A times B over C, this can be rewritten as AB over C. And in our equation, we have 1,250 miles times y sub 2 tanks over 1,250 miles. So we can rewrite the left-hand side of our equation as 1,250 miles times y sub 2 tanks over 1,250 miles. And in the same way, we can rewrite the right-hand side of the equation as 2 tanks times 1,250 miles over 500 miles. Which of the following is the next step in the solution of the proportion?
Good. C is our next step.
Click here as we continue to simplify our equation. When you're done with the video, be sure to click here to continue with your work. Our equation now looks like this. And we need to remember an important pattern. We can easily show with our rules that anything over itself is equal to 1. And we can use this pattern to simplify our equation. 1,250 over 1,250 is 1. The miles unit over the miles unit is equal to 1, just like x over x is equal to 1, times y sub 2 tanks is equal to, looking at the right-hand side of the equation, miles unit over miles unit is equal to 1 times the rest of the equation. Which of the following is the next step in the solution of the proportion?
Good. The proportion simplifies to be answer choice A.
Click here as we determine how many tanks of gas are needed for the trip. When you're done with the video, be sure to click here to continue with your work. Here is our equation. We have 1 times y sub 2 tanks on the left-hand side. And that will calculate to be simply y sub 2 tanks is equal to, we simply rearrange the number factors on the right-hand side of the equation. 2 times 1,250 times 1 tanks over 500. We can go on with our calculating using our calculator. 2 times 1,250 times 1 over 500 calculates to be 5. We can say y sub 2 tanks is equal to 5 tanks. At a first point in time, if the trip lasted 500 miles, it required 2 tanks of gas. At a second point in time, if the trip goes 1,250 miles, it will require 5 tanks of gas. We can say this because we solved a proportion, and we could solve the proportion because we knew that the variables y and x varied directly. The ratio of their values always calculated to be the same number. Which of the following is the next step in the solution of our proportion?
Good. Answer choice C is next.
Click here as we look at another important application of proportions in medicine. When you're done with the video, be sure to click here to continue with your work. Let's look at another type of problem that can be solved using proportions. If we assume that the weight of a patient and the amount of medicine that is required vary directly, we can solve this problem. If a patient that weighs 25 kilograms requires 5 milliliters of medicine, we want to figure out how many milliliters of medicine are required for a patient that weighs 40 kilograms. We can solve this problem using a proportion. We can let x equal the weight of the patient in kilograms, and y can represent the amount of medicine in milliliters. We can let x sub 1 represent the 25 kilogram weight, and y sub 1 the 5 milliliters of medicine. X sub 2 can represent the 40 kilogram weight, and y sub 2 is what we want to find. How many milliliters of medicine are required for a patient that weighs 40 kilograms? Let's organize our information into a table. At a first point in time, if x has the value 25 kilograms, then y has the value 5 milliliters. At a second point in time, if x has the value 40 kilograms, we want to figure out what the y value is at that point in time. We can use our proportion to solve this problem. Let's replace our variables in the proportion with our values from the problem. First of all, x sub 1 is 25 kilograms, and we replace x sub 1 with the value 25 kilograms. Y sub 1 is 5 milliliters, and we replace y sub 1 with 5 milliliters. X sub 2 is 40 kilograms, and we replace x sub 2 with the value 40 kilograms. And we want to find y sub 2, how many milliliters? Which of the following are the correct replacements in the proportion?
Good. Answer choice A are the correct replacements.
Click here as we begin to solve our proportion. When you're done with the video, be sure to click here to continue with your work. Our proportion is at this point right now. We have y sub 2 milliliters over 40 kilograms. We know that we must multiply this fraction on the left-hand side of the proportion by 40 kilograms in order to start to make it talk about y sub 2 all alone. So our first step is with the left-hand side of the proportion to multiply it by 40 kilograms. And our rules tell us that we must do the same thing to the right-hand side of the equation and multiply it by 40 kilograms as well in order to still have a true statement. Which of the following is a correct next step in solving the proportion?
Good. Answer choice C is the next step.
Click here as we go on with our solution of the proportion. When you're done with the video, be sure to click here to continue with your work. And our equation now looks like this. And we need to again remember an important pattern. Remember, if we have A times B over C, we can easily show with our rules that this can be written as A times B, over C. Looking at our equation on the left-hand side, we have 40 kilograms times y sub 2 milliliters over 40 kilograms. So we can rewrite the left-hand side of this equation as 40 kilograms times y sub 2 milliliters over 40 kilograms. And in the same way, we can rewrite the right-hand side of our equation as 5 milliliters times 40 kilograms over 25 kilograms. Which of the following is a correct next step in solving the proportion?
Nicely done. Answer choice B is correct.
Click here as we continue with our solution. When you're done with the video, be sure to click here to continue with your work. Our equation now looks like this. But we need to remember an important pattern. Using our rules, we can easily show that any expression over itself is equal to 1, as long as that expression is not equal to 0. We can use this pattern to help us simplify our equation. Notice on the left-hand side, we have 40 over 40 and kilograms over kilogram units, just like x over x. And on the right-hand side of the equation, we have kilogram unit over kilogram unit. We can begin to simplify. 40 over 40 is 1. Kilogram unit over kilogram unit is 1 times y sub 2 milliliters. And in the same way, on the right-hand side of the equation, kilograms over kilograms is 1 times the rest of the expression. Which of the following is a correct next step in simplifying and solving the proportion?
The proportion simplifies to be answer choice A. Good work.
Click here as we find out how much medicine our patient requires. When you're done with the video, be sure to click here to continue with your work. We are at this point right now, and we see that we have 1 times 1 times y sub 2 milliliters on the left-hand side of the equation. And we can write this as y sub 2 milliliters. Going to the right-hand side of the equation, we have 5 times the milliliters unit times 40 times 1. We can rearrange the order of the multiplying factors in the top of the fraction so that we can calculate more easily. And we can rewrite the top of this fraction as 5 times 40 times 1 milliliter unit all over 25. Now we can use our calculator to calculate 5 times 40 times 1 over 25, and that will calculate to be 8. So the result of our calculation will be y sub 2 milliliters is equal to 8 milliliters. And we can say, if at a first point in time, a patient that weighs 25 kilograms requires 5 milliliters of medicine, then at a second point in time, a patient that weighs 40 kilograms requires 8 milliliters of medicine. Again, this is all based on the assumption that the amount of medicine varies directly with the weight of the patient. If that isn't true, you need to be careful. You can make the patient worse rather than better. A patient that weighs 40 kilograms should receive how much medicine?
Nicely done. Our patient should receive 8 milliliters of medicine.
Click here as we use our math graphing calculator to solve proportions. When you're done with the video, be sure to click here to continue with your work. We can use the graphing calculator to solve proportion problems. And we are going to rework our medicine problem using the calculator. Remember, the problem was 25 kilograms of patient weight requires 5 milliliters of medicine. We wanted to know if a patient weighs 40 kilograms, how many milliliters of medicine are required. We need to remember that if y varies directly with x, that means that the ratio of the variable y over the variable x is always equal to the same value. And we can calculate that same value using any known values of x and y. Remember, we said that if y varies directly with x, that means that at any point in time, the value of y over the value of x, that ratio is equal to the same value. It is constant. And we can represent that idea with this equation, y over x equals k. K is a symbol, just like a variable, that represents a number, but it is called a constant because it is understood that the number it represents does not change during the course of a problem. We now have that y over x is a constant ratio, with the constant value being k. That means at any given point in time, the value of y over the value of x at that same point in time is equal to our constant value. And in our problem, y sub 1 is equal to 5, y at one point in time, and x is equal to 25 at that same point in time. So 5 over 25 equals our constant value. K can be written first, and on the other side of the equation, we can place 5 over 25. We now have that y over x equals the constant value k. And that constant value k is equal to 5 over 25. Using our rules, the transitive rule or the substitution rule, we can say y over x is equal to the value 5 over 25. We are at this point now. We have y over x is equal to 5 over 25. We need to change the form of this proportion so that we can put it into our calculator. We need to make this talk about y all alone. So our first step with this equation is going to be to multiply the left-hand side of the equation by x. And our rules say that we must do the same thing to the other side of the equation. Going further with our calculation, x times y over x will calculate to be y is equal to 5 over 25 times x. The equation y equals 5 over 25 times x is a form of the proportion relationship that we can put into the math graphing calculator. And we can then describe the relationship between x and y for many values of x and y. Here we have the equation for direct variation that we've been working with in the medicine problem. Remember we said a patient that weighs 25 kilograms requires 5 milliliters of medicine. The calculator, when we enter this equation into it, automatically calculates a table of values for a range of weights and measures of medicine. Here we see that our 25 kilogram weight requires 5 milliliters of medicine. A 28 kilogram weight requires 5.6 milliliters of medicine, and so on. We can move through our table, and just as we did by hand, we have that a 40 kilogram weight requires 8 milliliters. In the same way, we can express the direct variation in the traveling problem with this equation in our calculator. Remember we said that at one point in time, we used 2 tanks of gas to travel 500 miles. When we enter this equation into the calculator, it automatically creates a table of values again. And remember, we said we used 2 tanks of gas for a trip of 500 miles. The calculator does not normally carry units. And remember, we can go through the table. We said that we needed 2 tanks of gas for a trip of 500 miles. And if we scroll through the table, we will get the same result for a trip of 1,250 miles as we got by hand. A trip of 1,250 miles requires 5 tanks of gas. And again, we can solve our baking problem using our math graphing calculator. This equation expresses the direct variation between the number of bags of chocolate chips and the number of cookies that would be made. Remember we said that 1 bag of chocolate chips would make 40 cookies. And if we go to our table that the calculator automatically makes, we see that 40 cookies are created by 1 bag of chocolate chips. And if we scroll through our table, we can find out again how many bags of chocolate chips are needed to make 100 cookies. 100 cookies require 2.5 bags of chocolate chips, just as we found by hand. Using the calculator, a patient that weighs 28 kilograms should receive how many milliliters of medicine? Looking at our table, if the patient weighs 28 kilograms, the patient needs 5.6 milliliters of our medicine.
Good work. Using the calculator, a patient that weighs 28 kilograms should receive 5.6 milliliters of medicine.
Basic Algebra Concepts is an individualized, programmed learning approach to e-learning based on the work of B.F. Skinner, Norman Crowder, and others with early learning machines. Sample videos on the course content and shop pages demonstrate our approach. Some of our strategies focusing on the young learner are: third grade reading level. Writing is encouraged but not required. We've designed the simplest learning steps possible. There is a strong emphasis on pattern recognition. Each slide contains clear animation and narration. There are frequent low-level assessments designed to reinforce and motivate. The student is provided with immediate feedback on their responses, as well as positive reinforcement for correct responses. There is an extremely high level of interaction between the student and the program. The learning is self-paced. There is no homework, worksheets, or tests. There are assessments at every step of the learning process, designed for success and motivation.